All right, let's talk about mood cue. Let's start off with the circuit. Pretty simple. I mean, we got our servo motor here. It's connected to ground and 5 volts, and then the middle pin. Actually, it's not the middle pin. On ours, it's the orange pin. So you got brown to ground, red to plus 5 volts, and the orange wire gets connected to pin 9. And then it's got a decoupling capacitor put in correctly. The side that indicates negative signs have that connected to ground. So careful with that guy. It's a bit annoying to put a servo into a breadboard. So you got these guys. You're like, I got a whole line of it. What am I going to do with it? Well, you can just break off a chunk of 3. Whoop. Plug her in, and you're good to go. And if it falls out, you can shift this plastic piece on the metal bits by just shoving it into a table and pressing down. But yeah, that's how you connect it to the breadboard. A nice little trick. That'll get the servo working for you. It also has a potentiometer, again with the decoupling capacitor, so that doesn't cause havoc with your system. So any changes in power that this causes do not affect the rest of it. Anyway, so it's got one side of it connected to plus 5 volts, one side of it connected to ground, and the middle pin connected to A0, all set for analog read. And that's it. That's really it. We got the potentiometer we read off of, the servo, we tell it which angle to go to, and some decoupling capacitors. And so let's move on to the code. All right, first little bit of code. So first thing we got to do is we got to include the servo library. So there's a header file and this statement here. It's a preprocessor statement, so it happens before anything gets compiled, gets turned to machine code that your Arduino can read. It'll go through, find this file. It's got a list of places to look. And once it finds it, it just copies and pastes that whole file right where the include statement is. So that's what include statements do. But fortunately, that include statement, one of the things header files usually have is class definitions. So it tells our program how to make a servo object, because classes tell you how to make objects. So first thing we do, we make a servo called myServo that takes no parameters. So semicolon, we declare it here. So it stays in scope the whole time. And then let's move on. We have create a constant. We could just use a define statement here, which we'll learn about in a sec. So our potentiometer pin is A0, which we saw in the circuit. So just the middle pin of our potentiometer is connected to A0. So we've got an integer also that stays in scope all the time. So we declare it before any of our functions, called potval, which holds the value of our analog read of our potentiometer. And then we've got another thing that stays in scope, an int that holds our angle, our number of degrees our servo gets put to. So let's figure it out. Next line in setup. First thing we need is to make our myServo use the attach method to give it all the information it needs. This will work perfectly fine if you have the official Arduino kit, but if you're like me and have the Smraza one, or if you've got another conventional servo motor, you're going to have to get a bit more specific. So if you look down, you should see this. If you're using the servo and the Smraza kit, change this line, which we just looked at. So we not only got to tell it what pin to connect to, we also got to say how many microseconds the pulses should be wide. Every 20 seconds, 20 milliseconds to tell our servo to go to 0 degrees. And then how many microseconds wide our pulses should be every 20 milliseconds to make it be 180. So our sort of minimum pulse width and our maximum pulse width to control our angle. So we're going to have to use our fancier attach method. Going back to the code, that's the only difference. Wrong code. Sorry. Going back to our code. We've got to start talking to our Arduino at 9600 baud rate, or 9600 bits, ones and zeros per second. And then in our loop method, the thing that happens again and again and again, so every pass through the loop, our variable called potval will become equal to whatever we read off A0, whatever we read off the potentiometer. So we got some number between 0 and 1023 off our potentiometer. And then we will print the word potval and a space, and then our potentiometer value between 0 and 1023. And then we're going to figure out what angle we want to turn our servo to. So we want to convert our values we get off our potentiometer with analog read from 0 to 1023, and we want to convert that to a value between 0 and 179 or 180. 180 would work great too. So we make our angle variable equal to our map, our potentiometer value, our initial range, and our final range. And then we just want to print out our information. So we're continuing on the same line. Notice it hasn't had these are all print statements. They're not print line statements. So this is all in one line. And so we will print a space, a comma, a space, and then the word angle. And then finally we have a print line. So this is the last thing on this line, and it'll print the value of the angle. So the whole thing together figures out what angle we want to set our servo to, and then prints out our potentiometer, prints out the word potval, and then what our value we're analog reading off our potentiometer is, and then sort of space, and then the word angle, and then whatever value we've got off our we've gotten from our map function. So what angle we should turn our servo to, and then we just got to turn our servo to it. So if we look down below, we've got my servo dot right, and then whatever angle it's supposed to go to. And then we're delaying 15 milliseconds, so it's got time to get to where it needs to go. And that's the whole circuit. Nice and easy. Thanks for listening.